Hello. Hi guys, good morning. Welcome back to a new video. Ki haal chal sab changa si? I hope that you guys are doing good. In this, we're going to see both the problems: minimum time to revert work to initial state 1 and minimum time to revert word to initial state 2. It is just that, okay, it is a normal approach, brute force approach. It is the most optimal approach which we will take. The only difference is in the constraints. So you can see the constraints are loose and you can try for much bigger thing. With n as 50, you can try for n cube, n h power 4 also, all that stuff. But you will see that we will simply go on and see the n square thing. But this part in this, you cannot do even n square. The max you can do is n log n, but still we will do it in O of n. Again, we will see in very deep that this question can be confusing for most of the people, but this video will solve all your doubts. Cool. Let's start off what the problem says. Problem just simply states one thing, that I am given a string of word and an integer k, and at every second I must perform the following operation. What operation I can perform is I will remove the first k characters of the word, which means if this is a word, again I will represent every character by a gula round. So I can remove the first k characters, and when I remove them, I will have to append any k characters in the end. Again, this is I am removing ABC, which is fixed character, what I have to remove from the starting. In the end, I can insert or basically put any characters, add any k characters in the end of the word. Now, again, they have mentioned that any characters, which means it is not needed for them to be same as what you have removed from the very beginning. Now, it just says please return the minimum time, which is for sure greater than 0. Again, this is another fact. Return that minimum time which is greater than 0 required for the word to revert to its initial state. Now, after removing the starting k characters, putting any k characters in the end, I have to keep on doing this operation until I get the exact same string which was the input string. Now, for sure, you might say, Aryan, by default, without even touching it, I have the input string same as that of the original string. I have not touched it. That's the reason they have mentioned that once you will have to replace, or basically you will have to put, or basically remove the starting characters and put them in the end. Once you have to do it. And now how many times you have to perform it to get the back initial state? That's the answer. That's the minimum number of time which you have to get. Let's see with example what the problem says. Let's say take this example, A B A C A B A. Now k is 3, which means at every operation I can perform, I can remove the starting k characters and put them in the end. Again, not put them, all of them, but put any of the 3 characters in the end. So what I will do is I will have these k characters in the very beginning. I know one thing, I can remove them. Okay, I'll remove them and I can insert any k characters. Okay, I inserted these characters in the end. Again, I have left it as blank. The reason is I can insert any characters. And Aryan, why not you are applying your mind and placing the characters which should have been there? Because I don't want to take a risk. I can place any character, right? So when I will reach the super end, then I will just try, okay, what to actually place them to actually make them equal. So, okay, I just left them blank. Blank means I can put any characters whatsoever at this location. Okay, now if I go and ask you, I have done one step, which means I have removed starting k characters and put them in. Now, if I ask you, is my current state equal to my initial state? A, B, A, C. So you will just start checking. Okay, Aryan, I will check. Okay, I'll check A. Is it matching with C? Nah, even the first character itself is not matching. So simply you can go on and try for the next step. Okay, in the next step, I will take the starting k characters and put ending k characters. So I'll remove them and I will have ending k characters. I will put ending k characters. Now you have done 2 steps. Now your current string is like this. Now I again go and have a check. Okay, I have done 2 steps. Now my current string is like this, because now my question is, do I need to do a 3rd step or not? That's a question. So I'll go and ask him, bro, is the current state and this state, which means is the initial state and the current state matching or not? So you might say, okay, Aryan, A and A are matching. Okay, B and blank. Remember, blank means you can place any characters, which means you can try to match it. If it is a B here, I'll place a B here. If it is a A here, I'll place a A here. If it's a C here, I'll place a C here. If it's a A here, I'll place a A here. If it's a B here, I'll place a B here. So if it's a A here, I'll place a A here. So that's how. Blank means I can put any character, so I'll just for sure will match. I'll for sure match. So you saw 2 operations or 2 time was the required, was the minimum time possible. 2 is the minimum time possible. Maximum can be anything. Keep on placing, keep on removing starting characters, keep on putting in end, keep on going it. That's the maximum time. Minimum time I want, that's 2. Okay, let's see another example. So in this again, see all these examples very carefully, because from all of them only I will derive all the solutions. I will not take any new examples. I'll use all of them only. I'll use only these examples only. So please see them very carefully. Okay, next characters, word K is 4, which means firstly, you will have to perform one operation. Okay, I will remove starting K characters and place ending K characters, any K characters. I'll remove them. I get a B, and ending K characters, anything I can put. Now, okay, one operation done. I will compare this specific new string formed with the original string. Is it matching or not? So what to do? How to match? Simply check. Okay, A and A matching, yeah, matching. B and B matching, yeah, matching. A and A matching, yeah, matching. C, oh, it's a blank. Oh, blank, which means okay, afterwards everything will match. Okay, no worries. So simply match. Oh, you saw, simply match. Everything matched. Thus, in one operation itself, it matched with my string. Thus, operation required is a 1. Okay, great. Let's see the last example. Okay, this is a string. My K is 2. Again, I will do or perform one operation. When I perform this operation, these 2 are gone. Okay, and then I will place them in the end. Okay, great. Now, this is the string. Try to match it with the input string. Okay, A and C, not matching. Okay, which means I have to again apply the operation. Again apply, remove this from that. Again, I'll remove only 2 characters because my K is 2. My K is 2. Okay, remove them, remove these 2 characters, remove them. Again, place the ending 2 characters, any characters. Now, again, this is the current state. Operation done. So far are 2 operations. Now match it. A, okay, A matching, okay, A is matching A, okay, B is matching, okay, B is matching, C matching, okay, yeah, C is matching, B, oh, it is a D, it did not match. Okay, no worries, it did not match, no worries, no worries, apply one more operation. Okay, take the starting K characters, remove them and put apply ending 2 characters, Now again, go and match CD, it is a A. It will not match. Okay, again apply it, operation. Okay, I'll again apply, remove starting 2 characters and put the ending 2 characters. Now it is a blank string. Blank string will always match. Now, if you look carefully, how many number of steps? Now you saw the entire string become blank, and as soon as the entire string becomes blank, it is for sure always possible. So now I'm asking you, this you can for sure see is the worst possible case. Because you can see, ultimately in the end, I had made all the blank boxes, and blank boxes I can place anything. So this is the worst possible case, which means no match whatsoever, and I have reached the super end. So it is representation of your worst possible case. So if I ask you how many operations were there, you will say simply, I can easily see it is 1, 2, 3 and 4. In 4 operations, you actually made the entire string as blank. So in mathematical terms, what you can say? In the first operation, you transferred 2, or basically you can say that you removed 2 characters. Okay, 2 characters removed in the first operation. In the next operation, other 2 characters are removed. In the next operation, other characters are removed. In the next operation, other 2 characters are removed. So I can say in the first operation, K characters are removed. In the next operation, again K characters are removed. In the next operation, again K characters are removed. In the next operation, again K characters are removed. Now, if I want to know how many such Ks are there, so let's say K is occurring Aryan number of times, right? My variable name is very bad, but no worries. K is occurring Aryan number of times, and I know that K length is N. So how many times the operation Aryan will perform? So Aryan will perform N by K times the operations. As you can see, N was here 8 and K was 2. So I perform operation 4 times. A simple algebra. Now, are you saying Aryan in the worst case operations required are N by K? Are you saying that? Maybe, maybe not. Aryan, why maybe not? Because here you considered the complete division, which means okay, K, your group was forming complete group, K2, and the length was 8 itself. So it was forming a complete group. What if it does not form the complete group? Which means, what if N mod K is not equal to 0? So let's see this example. Again, A, B, C, D, E, your K was 2. Again, you will just simply, again, it will not match, so I'll just simply go on and show you the worst possible case. So in starting K characters, go and put ending 2 characters. Starting K characters, remove it, ending 2 characters, right? Then, okay, again, E is still there, which is still not matching with the input string, which was A, B, C, D, E. So for sure, again, you have to take this starting two characters. Although, if you see, it will be just one character which needs to be replaced, but I know one thing, that I will have to for sure take the starting key characters. I cannot take, okay, less than or at most K. Exactly K characters I have to take. So I'll take this E and a blank also, because ultimately my aim was to replace a E. Now with this, I will actually get the ending two characters. So yeah, so here you can easily see that I formed a group of 2 to 2. So which means a group of K, but it can be possible that the last group is not formed with a group of K. So I have to complete that with another blank I used, as you can see here also. So I can easily say, okay, K into Aryan is actually equal to N. So Aryan, which is number of times, will actually be N by K. Right, N by K. But by this you will see, okay, you are actually taking a ceil value. So this is nothing but N by K ceil value, so as to give me all the possible times I can have my K. So in this case, when your N mod K is not equal to 0, then you know that you will take a ceil value, which means N by K ceil value. So here in this case, you know, we had 3 steps. How? 5 by 2 ceil value is a 3. It's 3. Floor values are 2, but ceil values are 3. That's the reason my operations required were a 3. So now you know, in the worst possible case, operations required will be a 3. Now coming back, how will you find the answer? How will you find the answer? Simply, as we did earlier only. What we did, if you remember, we did simply one thing, that we simply thought, okay, in the first operation, I will remove the first K characters and then I will put them in the end. Now putting them in the end, okay, for sure putting them in the end. So the state will become something like this: C, B, A, B, C, D, which means this specific suffix, and then other blank characters. So now if you imagine, if you have remembered, I matched this string with the input string to know if the current step was good or not, or which means if I have to try for next step or not. And if it did not match, which means, okay, I'll just simply match this input string with my current string and know if this is matching or not. So simply I can easily say one thing also, right? I am matching this specific suffix of length, what? 1, 2, 3, 4, 5, 6. So length is 6. I know the length of suffix is 6. So I will just simply go and match the 6 length prefix. 1, 2, 3, 4, 5, 6. I'll match 6 length prefix. Aryan, why not the complete length? Because I know one thing for sure, the remaining are blanks. So for blanks, I never need to check anything. So now I have known that I will, okay, after every operation, I will check the suffix portion with that length prefix portion in my string. If it is matching, voila, I can end my loop, or basically end my trials, which I was doing. If it does not, which means I have to again go and try for next operation. And what is the next operation? Simply again go and remove the starting K characters and put them in the ending K. What it means now is you will just get the shift. You will now shift to next ending suffix. So now I will say that this is now my new suffix. As you can see also, this is now your new suffix. A, B, C, D. So this is now your new suffix, because this CB has also gone in the end, right? So now this is a new suffix. So now you will match this new suffix with the input length. Again, length, you will match equally, length of 4. Because you know one thing, that remaining they will for sure match towards a blank. So that is how you can simply go and keep on matching. How to do it in the code terms? So you know one thing, that in the very beginning, you will have to apply one operation at least, which means starting K characters will for sure go away. When I say for sure go away, which means what is the portion of the suffix which you should start comparing, starting from I equal to K, because I equal to K means the previous K characters are gone. So I equal to K is the starting character, and by your terms I equal to is the index. Starting from this index up till the super end, this is a suffix. Compare that with the prefix of the same length. And how to know the length? Simply, no worries, simply you know that this is currently your character. You know, okay, it's nothing but the k characters are gone. If k characters are gone, if the all number of characters entirely total you have n, so the remaining are n minus k. So starting from index 0, you know that you have to take n minus k characters, and then compare that with the suffix, and that's it. If it matches, great. Simply break out, you have done one operation, and that was good operation. If it does not, which means, okay, in the next operation, other k characters will go away. So what will happen? Your I will be here at 2k. So you will simply add your next k into your previous I. So I now will become 2k, or you can say I will become your 4. Now, starting from this specific suffix, you will compare same length, okay? Same length of 4, I will start compare with the prefix. If it matches, great. If it does not match, simply try on for the next k characters, which means again, remove the k characters. Now your I will become a 3k, okay? And again, up till the super end, compare that with the prefix. Same length, and that's how you can simply get this solved. So now you know, and again, you will keep on going. Ultimately, if you cannot find, in worst case, you fall short of the answer. The answer is n by k seal value. And to represent the same seal value, you can also write the same thing as n plus k minus 1 by k. Both are same, right? This is the same thing. So now you know one thing, that in the worst case, still, if in the between you cannot find an answer, worst case, you know the answer for sure. Now, so if I just look you back, that at a specific I, you know one thing, that you will compare the specific suffix with the prefix. So okay, if I imagine that my suffix starts matching with the prefix, then what is the answer? So you know that, okay, you are going on the ith loop, which means if you remember, your I was 4, which means I was 2k. So if your I was at 4, and then if your suffix got matched with the prefix, which means these two will go in the end, and then I will form my good answer. That is what we have seen. But Aryan, what is the number of steps required, like steps taken? For sure, the steps taken will be, okay, you have taken 2 steps, which means your I was 4, your k was 2, which means 4 characters in a group of 2 have gone away. So answer will be I by k. Number of times, which means if you see, you had taken this, I represents I have moved my previous 4 characters, and I know that I can move my characters in a group of k. So k moved, I know 4 moved. So how many times the group of k moved? Simply I by 4, I by k. So if my I is 4, k is 2, I know my my groups moved, 2 groups moved. And that's how I can simply say that my time required was 2. Cool. Thus my number of steps or number of time required will be 2. Now the code is actually pretty simple, exactly same as what we discussed. I will simply start my I with a k. What it means, that starting k characters will for sure have to go in the end. When I say I equal to k, I will compare my starting from the ith character, which means starting from I equal to k up to the super end, it is the suffix. So starting from I up till the length of n minus I will be the suffix. This suffix of length n minus I should be equal to my prefix starting from index 0 of the same length, which is n minus I. If this matches, which means if my suffix and my prefix matches, so after this movement of the k characters at this index, it is good. If something is good, then simply return number of times you have to apply this operation, which is I by k. And again, in worst case, what if it does not match any time? No worries. In the worst case, your answer will be n by k seal value, which is n, or you can also write the same thing as n plus k minus 1, and that is your answer. But you will see the time complexity of this operation will be nothing but this will take O of n time to go on to all the in the jump of k, still you are going on to all the characters. So it is O of n. But to compare these strings, again it's a O of n operation. So in total it is O of n square operation. Space is O of 1 because of no extra space used. Now, if we go back and look, for sure O of n square will do not work for the hard problem. So let's see the improvisation. Again, this itself was actually a hard problem, the above which we saw, but let's see the improvisation. Now, if you had not seen or learned or heard about the thing which I have been speaking so far is again, I was just matching, I was just referring or speaking one statement. If you had focused on my words many times, I spoke one statement like, what is the suffix which was matching your prefix? I had spoken this word many times. What is your suffix which was matching your prefix of the same length? And the same thing is done in the smallest possible time by KMP. If you have not watched this KMP lecture, just go again. I will paste the link in the description as well as on the comment. But still, if I forget and all that stuff, just go and write KMP by Aryan Mittal. You will get the video. Watch this video of KMP because it is a proper intuition of how KMP works. Many videos on YouTube will tell you about KMP and stuff. Do this, do that. It is the matching. It is the longest proper suffix which matches to your prefix, all that stuff. But this gives you entire proof of what everything and how everything works with intuition. So please go and watch this. Even if you have watched other KMP videos, still I'll highly recommend go watch this video. Now coming on back, that now you know that how KMP is and what KMP is, because, and it is not that okay, I brought my KMP out of my picture somewhere. No, I was many times mentioning longest suffix. As in, I was not mentioning longest, but I was mentioning, okay, what is the suffix which is matching my prefix? I was again and again mentioning that, and KMP gives me the longest suffix which matches my prefix. So I might take the use of that. How, Aryan? How? Let's see. Let's take the same example 2, which we saw. Now, if I just see one thing, that what I was doing, I was taking the key elements and then putting them in the end, and then I had whatsoever is remaining, whatsoever suffix was remaining, I was comparing that suffix with the same string, because again input string is nothing but A, B, A, C, A, B, A. So I was comparing this suffix with the input string, which I can easily say as prefix of that input string of the same length. Now, rather than finding that entire length again and again, I will go and simply ask, bro, I know KMP, you are very good and you are very great at computing suffix and prefix matches. Which means I will go and ask my KMP. My KMP will say, for this specific string, for this specific string, again, if I make the KMP LPS array, which means longest prefix which matches my suffix, if all these terms are very new to you, please go and watch the KMP lecture. But now if you had, let's say if you had an idea, let's say if you still don't want to watch, but if you still have a small idea of how KMP works, let's come to this video. So right now you can see, okay, this LPS array will become like 0, 0, 1, 0, 1, 2 and 3. This is how my LPS array will become. Now for the ones who don't know much, this LPS simply says that if I end exactly at this location, now this is my main string. So if I am ending at this location, so this is the longest prefix of length 1 which will match my suffix. If I length add exactly here, so this is my longest suffix of length 2 which will match exactly my prefix. So that is how my LPS array is built. It's saying if I exactly at the end at that location. Now coming on back, my LPS array says that, okay, Aryan, I can easily see that if you had this input string, your suffix was this length of 3 and it is matching your prefix, which means input. So I know one thing, it is matching my input. Now what it means is that whatsoever is the remaining element, again, mark my words, whatsoever I am saying, don't think anything else apart from it, whatsoever I am saying. So if I am saying that this was a suffix which was matching my prefix, anything other than that, if I can shift that to the end, if I can just simply remove it and shift that to the end, so this suffix will actually now become my prefix, and I know it is matching, so I don't have to match the O of n operation which I was doing by myself in that O of n square code. If you remember, I will go on to all the groups, but then I was matching the strings by manually, like comparing the strings. So that was increasing my time. So now I am saying, if I anyhow the remaining portion, again, let's name these things. Let's name this as maximum LPS length. Right, so remaining length will be n minus max LPS length. This will be the remaining length. Now I am saying, if anyhow I can move this n minus max LPS length to the super end, then I will simply get this suffix as the new prefix of this new string, in which ending are blank operators, and I know for sure that this is actually matching with my prefix. So blank will for sure match. This suffix was already matching with my prefix, so now this string is actually a good string. So now you might ask, Aryan, what is the number of operations required? Operations required are, this was a n minus max LPS as the length. The remaining length for this specific portion is n minus max LPS. This was the portion. If this is the portion, I know in one time I can transfer k characters. So for sure you can simply say that number of times required will be n minus this LPS, which is the specific length which I will have to remove, by k. It is a number of operations or number of times I will have to perform this operation. Now the first obvious thing which would have come to your mind is, Aryan, can't, like, okay, you are saying, like, first obvious thing which would have come to your mind is that you are taking this, but what if I had a bigger LPS string? Bro, if you had a bigger LPS string, no, then your last character of the LPS would have given you that bigger length. And the same length I'm just taking the last character length, which is saying this is the biggest length possible. This is the biggest length. 3 is the biggest length possible. So this will give me the biggest length, which is the biggest suffix, which is matching my prefix. So this is the best possible case which you can do. But so one thing is for sure, which means this n, the LPS length was 3. So remaining length, okay, n was 7. Remaining length will be 7 minus max LPS length, which is 4. So now I have 4 characters. I have to move them in a bunch of k. How many times I will move it? Simply this length 4 by k. And if you remembered, my k in this question was 4 itself. So I would just need one operation, which is nothing but saying it will be n minus max LPS by k. Simply giving us as one operation. Okay. Oh, sorry. I just moved it. Cool. So it will give me as just simply one operation. As you can see, my k was 4. I'll just simply move this, and I know this is my matching, so it will be required by 4, just one operation. For a quick change, what if your k would have been 2? Now okay, you had simply n minus max LPS. So this is a 4. Length is 4, which you have to move. You can move in a bunch of 2. So how many times you have to do the movement? Simply 4 by 2. Simply 4 by 2, it is a 2. So you will do 2 movements. One movement of this and other movement of this. Cool. Now the same thing comes in picture. Aryan, now you imagine one thing, that for sure you will be able to move, which means for sure you will be able to make a group of those remaining characters. What if I'm not able to move? And because here you are saying no, that you will do a simple division. One obvious thing, earlier last time also you were doing a simple division, but then you showed us other case also where it can actually give us multiple, like, bigger answer. Same in this case also. And also I can simply say that you also imagine right here that you will move this entire group in a bunch entirely. But I am saying right now is, what if I could be moving this entire group of 3? But I know again this C will never match, so you will again have to move a group of this specific 3. So how will you handle this specific case? Oh yeah, that's a great idea for you. Let's see. Let's handle the specific case with the same example. Example number 1. Now, as you can simply see that if I make the LPS array, same LPS array will be built, but the LPS, max LPS length is a 3, which means length suffix of 3 is matching a prefix of my 3. So remaining characters are 4. As you can see, remaining characters are 4. 4 characters are remaining. If the 4 characters are remaining, now it's very much hard for you. What is hard for you? You know your k is 3. So in one operation, you can just shift k characters. Okay, these are gone. Let's say these are gone. But you still know that your suffix matching was starting from this character. So still this C is like a hamper to you. You have to remove this also. But if you go on removing this, then you have to remove the starting, like you have to remove the next k characters, which means this also will go away. Now your remaining thing is the A. Remember, earlier your suffix length was of length 3, but now your remaining suffix length has become only equal to your 1, which you can actually utilize. But the issue is how to find that. How to find that? Simply, we will use the same LPS array logic. Now, here comes the part where you should be knowing a bit backwards intuition, and you should not have done a ratification of how you build the LPS array, and that I've clearly explained in the KMP video, because many videos on the internet just make you ratification of KMP. And again, I'll say that KMP is actually a bit tricky to understand rather than Rabin Carp, but still, if you know that people use Z algorithm also, Z is on top of KMP. So it is the exact same logic, it's just on top of KMP. So for sure, KMP and Rabin Carp will solve all your problems. Rabin Carp, I don't recommend it, because the reason is you will, again, many people on internet just show single hash Rabin Carp. Again, when I say hash, I actually mean that in Rabin Carp, you are doing a like 1E, like the let's say if you have 26 characters, so reach for 26, all that stuff, and mod with the prime number. That is a single hash. This has a chance of collision. So in worst case, it is O of n square. But in Rabin Carp algorithm also, there is a concept of known as double hash, which will give you the most optimal time complexity. Now, if you're wondering that Aryan, where I can find this, all that stuff, so basically I have planned the entire video on Rabin Carp. It is just that it will come in. See, this is the entire video of Rabin Carp. In this, we have taught everything, starting from single hash, double hash, all that stuff, and entire thing we have taught in this specific code, like in the specific Rabin Carp video, like single hash, double hash. As you can see, Rabin Carp, double hash. This has the complexity of R O of n plus m, and this is the worst case time complexity of Rabin Carp. Why is that the case? Because of the probability. If you go back and I show you, because okay, yeah, like I don't think it is there, yeah, no worries, but yeah, it has the least probability, which is 1 raised to 10 raised to 10. This is a probability of a collision, which is negligible. But in a single hash, there is a probability of collision. So that's the reason this is the most optimal Rabin Carp approach, which you should take. But people still don't teach it. But yeah, we will see this in a 100 like our 100 days 100K placement challenge. Now coming on back to KMP, if you had known KMP, then what this value represents is a 3, saying that this is the suffix which is matching my prefix. As you can see, it matches your prefix also. Now you can simply go on and move to your, again, when we move on, we actually move on to the index. In a KMP, when we have to move back, we move back with the index value. But you will see that you just now want that if I say this as a max LPS length, so remaining length was n minus max LPS. Now this was not divisible. By my what? K. Now, which means I will have to shrink this max LPS length. I will try for a shorter max LPS length, shorter, which means I will try to shrink this length. I'll keep on shrinking this length. Now, to shrink a length, and why Aryan we are shrinking the length? Because we want this value to increase, and when this will actually start increasing, I can encounter a value where n minus max LPS mod k becomes a 0, which means now that portion will be divisible by k. So I will be able to simply transfer the entire portion to my end. But I will keep on reducing that optimally. I'll keep on reducing my max LPS length optimally, which means, okay, this is the max LPS length right now. I'll reduce that. Why I'm reducing it? Because, okay, ultimately, I want minimum possible operations, which means operations as in the number of movements. I want minimum possible number of movements, and for those movements, if I want minimum possible, so the length also should be as minimum as possible. So it's a reason again, when I say length should be as minimum as possible, I mean this specific length. But as you can see, if it is not divisible, I will have to increase the length, which indirectly means I have to decrease this max LPS length. Now, if you go back, then you will see again, by default what happens is you will try to query and get the index 3, but we actually go and try for if this let's say ML is max LPS. Now the max LPS value is 3. So I will go and try for max LPS minus 1 index. Max LPS minus 1 index. This is ML minus 1 as the index. On that index, what is the value? The value is 1. What this value means? First thing, see, if I go back and show you, this 3 means that your suffix was matching your prefix. Okay, let's take the blue color only. Your suffix was matching your prefix. Now as you go on to this ML, now you go on to ML minus 1. So now you know one thing, you are at an index which was matching this, it is exactly matching. You can see the blue portion, it is exactly matching. And this is how the LPS is built. Now we know we have to shrink the LPS length, which means again, please make sure that this entire portion on the right side is the exact replica of left side. So whatsoever I will do on the left side, it will automatically infer that everything can be done on the right side also. So now I will do operation on the left side. That okay, I am at this specific index. The LPS shows me as a value 1. Now you saw LPS value shrinked from 3 to 1, but Aryan will say, okay, LPS value shrinked to 1. It is for the specific left portion, right? This one says that this is the suffix which matches my prefix. It says this, but if you remember, I am saying this is exact replica of this portion because we have gone from here to here. So if I'm saying that this is the suffix, this ending at here, if this suffix is equal to this prefix of length 1, I can also say the same thing as that this specific suffix is matching with this specific prefix, and thus you saw that your max LPS length got shrinked. Earlier it was 3, now it became a 1. It is the next shorter max LPS length which you can have and you can try for. So now you have seen that your max LPS length has now become a 1. And now the remaining length will be n minus max LPS length. N was simply a 7 by default, minus 1, it will give you a 6. So now you have your new value as n minus max LPS, which is 6. It is modulo by 3, will give you a 0. So now you can simply get and say, I will take 2 operations, which will, okay, first 3 operations, these 3 value will go in the end. Next operation, these 3 value will go in the end. And that's how you have used 2 operations. So that is how you have actually reduced your max LPS length. Just have a quick recap. Max LPS length, again, this max LPS, let's name it as ML, right? ML. So I'll say that while my ML is more than 0, right? And again, my main task was that n minus ml. If you remember, this was my main task. N minus ml mod k. If this is not equal to 0, then what I should do? I should say that ml minus 1 LPS value of that assigned to my ml, and then keep on repeating this while loop. Keep on repeating this while loop. So ml, if you remember, your ml was a 3. You went on to index 2, ml minus 1. You got its LPS value. LPS value will be a 1, and this is your new ML value. And then you will try. But here you will see that this will become a 0, so it will break out, and that's how. And again, this entire exact same logic is of LPS also. In LPS also, the exact same logic is inferred so as to build the better subarray, better answer. So now you have known one thing, that again, if your n minus LPS mod k becomes 0, then your answer is n minus LPS by k. Again, if your n minus LPS mod k becomes 0, Aryan, but still, if it is not, no worries. In worst case, if your again, this loop will try to make sure that your n minus ml mod k becomes 0. But Aryan, in worst case, if it cannot make my n minus ml mod k as 0, still your ml will become 0, which means your maximum LPS length suffix which matches your prefix will be a 0, which means you have to convert the entire string as a blanks. This is the worst case which we have seen already. So for the worst case, we know answer is n by k seal value. This is nothing but n plus k minus 1, and this is the only answer. Now I will use my KMP template exact same template I have showed you, and I use always the same template. Now again, I just change it. Here I will simply return my entire LPS array which I have built, or sometimes if I just need the length, I just simply run the length, which is the last character. But here I just simply have the entire LPS array. Now I'll simply have the same max LPS. Max LPS is the maximum suffix which is matching my prefix. It is LPS of n-1. Now as I showed you in the loop also, that ML, while ML is more than 0 and your n minus ML mod k, if it is not equal to 0, simply keep assigning ML is equal to LPS of ML minus 1. Now if it comes out, either your ML is 0 or your n minus ML mod k is 0, right? Now if your n minus ML mod k is 0, then your answer is n minus ML by k. Else in worst case you have to make all the blanks. That will give you a n by k seal value, which is nothing but n plus k minus 1 by k. And with this, because of using your KMP, you have solved it in O of n time, and space is again O of n. Now you will see on again many platforms and stuff, Z algorithm. Z is nothing but the on top of KMP, we have built a Z algorithm, which simply says starting from that index, what is the length of my substring which matches my prefix. But I say that we can derive that the same thing. Don't make your life complex. Z has multiple other use cases. This is not built for Z. Z is okay. How many times you have seen a problem with Z? Never, right? So it's the reason. Don't make your life complex by learning another thing which you might not even remember or might not even use that. Just start applying the things which you know. You know KMP. You have, again, in the last 1 week, I guess in the 1.5 week, we have seen another problem of KMP also. So please use KMP, and that's how you can solve it. Bye bye. Take care. बहुत डांट दिया आज, bye bye.